A second. Okay, that's good.
Did you choose the option for uploading onto the cloud?
Yes.
Okay, thank
Mm-hmm. So we're going to talk about the curriculum overview first, and you hopefully by then have a good idea on we are going to be learning the next 5 weeks, or not including this week. And then we'll go over some topics related to functions, including their definition, how to graph them, rate of change, and then composition along with inverse.
So
So
first
for its
going,
curriculum
okay.
okay, I got you. Um, Fairly simple. We're going to first talk about functions review, which is what we are going to do today. And then later this week, you'll see introduction to trigonometry. And then the next week, you'll be going all the way into trigonometry, including identities and applications. And then the week after, you spend your entire week three on parameterization and trigonometric coordinate systems. And then you spend the next week learning about complex numbers along with their connection to trigonometry. And then you'll be learning about vectors and matrices. And that's the game plan for the next 5 weeks.
So first going off to function basics. So before everything starts, I want to define domain and range. We define domain as something that consists all the values we are able to input to the function and get an output. And we define a range as something that consists all the values that can come out of a function. And the purpose of defining domain and range is that not all the functions can have all real numbers as their input or their outputs. So we want to make sure that we are considering what can and cannot be included in a domain and range when we're looking at each function. So giving two examples, the first example is y equals to 2x plus 3. In this function, the domain would be all real numbers as you can input all the real numbers into the function. And the range is also going to be all real numbers because depending on the x input, you can get all possible values as real numbers out of the function. However, when we look at the next example, a function that is y equals to 1 over x minus 3. In this function, the denominator cannot be 0, and thus x cannot be 3. So the domain of the function will be all real numbers except for 3, and the range of the function will be all real numbers except for 0. So there are kind of function called real valued function, aka real function. That is a function that can only output real numbers. And in a lot of cases, we use interval notation to express the domain and the range of a function when we talk about those functions. Usually we use parentheses to indicate the boundary values that are not included, and some and the interval in the interval notations, if both sides does have parentheses, we also call it an open interval. And when we go indicate the values are included in a boundary as values, we use brackets, and that's also called a closed intervals. And the following are some examples of how we use interval notation. For example, if the x value can only be between 3 and 5, and 3 and 5 are not included, then we use brackets. However, if the values are considered included in the interval, then if they're not included, we use parentheses. And if they are included, we use brackets. And when we are writing um the domain or the range of the function as all real numbers, we can write it in interval notation as in negative infinity to positive infinity, or negative infinity to infinity, or we can also write it as in x belongs to all real numbers. So here's a quick question about what does this interval notation represent. You guys can type your answer into the chat, and we will tell you the correct answer at the end.
Okay, so I've gotten some correct answers so far.
Okay, I see a lot of E in the answer. So that is the correct answer in that interval notation.
Okay, do anyone has any question on this, or can we move on? All right, sounds good.
Great. So an example problem is a function f of x equals to 2x squared minus 3. If you guys want to try, you guys can try A and type the answer in the chat.
All right, how about part B? 5 is correct for part A. Let me just do it here. Okay, I like how some of you mentioned LaTeX. For part B, we're gonna find for some value of t, we have f of t equals 247. So 2 times some t is minus 3 is equal to 47. You should be able to solve this equation and get 50 here. So yeah, it is plus minus 5. And do not forget about the negative solution of minus 5. How about the third part C? Right, so we can kind of treat this as a composite function, which we're going to dive into details later. But imagine like this is like something, and you plug this into the entirety of x. So the x here is replaced with whatever this is. Right, so therefore we have this. And then algebraically you can expand it. 9x squared plus 6x plus 1 minus 3. And then the coefficient of the x squared term is 18. And then let me move the oh, never mind. And then the coefficient of the x term is 12 and then minus 1. So the popular answer in the chat is indeed correct.
Okay, so now that we know a basic function, a function can be defined to accept multiple inputs. However, for example, let's see this function as g of a, b, and c can equals to 3a minus 2b plus 7c squared. So do you guys want to try question number 1 and type the answer in the chat?
All right, so multivariable functions are not fundamentally different from the single variable functions besides that they have multiple variables. So 3 times 3 minus 2 times -5 plus 7 times -1 squared. All right, 26 is correct. How about B? Okay, it's probably correct. So we have 3b minus But also the B, this is a B here and this is a B here, so like do not just plug the B here into this. I feel like that's what the problem writer was thinking about when they wrote the problem. And it's 4 plus 7 is 27. The 21, what am I saying? Um, minus 3. So
18.
yeah, 6 should be correct.
Yes. So here's another problem. Suppose that function t of x is equal to ax to the fourth power plus bx squared plus x plus 5, where a and b are constants. And in this problem, we will find t of 4 if t negative 4 is equal to 3. So try to use t negative 4 equals to 3 to write an equation in terms of a and b.
Okay, that's a good first step. So we have t of negative 4. Directly plugging it in results in times 4 to the fourth plus b times 16 plus, or I should say minus 4 plus 5 is equal to 3. Yeah, you're getting an equation. So
And then we can try to solve the equation.
no, I don't think it's possible.
Okay, but like simplify it in a way.
Okay, yeah.
And then after that, we can express t of 4 in terms of a and b.
All right, so nobody is typing it down, so I'm just gonna write it. It should be fairly simple for you guys. Right. Interestingly, we can notice that here this thing is the same as this thing. So therefore, what is T of 4? Right. 11 should be correct. Because this entire thing is equal to 2, as we found earlier. Plus 4 plus 5, which is 11. Alright, this is one way to solve this problem by following the part A and part B. But if you want to be fancier, you can also use the fact that T of x minus x is an even function. Do you guys know what's even function? If you guys know it, I can. Well, how about
I
this? If
think
you guys
we're
understand what is an even function, you guys probably know how to solve it with even function. And if you guys do not, then you guys probably will not um understand it very quickly. So just putting that out there for those of you who know what's even functions.
so now we're gonna find the domain and the range of each of the following functions, starting with a. I think that's already in the example. Can we skip to b? We'll skip to b, starting with number b.
There's some notations that when you're denoting the domain of a function, often you can write d sub g. Or in LaTeX you can write d sub g. It's notations. And then for range it's just r. I don't really remember if you have to bold it. Maybe you have to math BB or something like that. I feel like in this case, the mean should be pretty obvious. It is range. It is real all real numbers besides one. You can write this symbol. Or I don't know. I've seen people are using this notation like directly as a minus sign. And by the way, this is how you'd write the set of all real numbers.
Or you can write the domain as in like negative infinity to 1 and 1 infinity.
Yay.
Yay.
And this is the union, I think.
Yes.
Yay. What is, oh, actually, I was looking at C, I some difference. What is the range of C? Can somebody type it down? Should be all real numbers besides a single value, right? Can we see in this case?
I think it's all real numbers.
Really? Am I
Mm-hmm.
trolling?
Mm-hmm.
Wait, to confirm, I just decimals it. Can it be a 2? Alright, you know what, let's verify. So 2t, let's assume that this is equal to 2, and then we multiply here. Right, so therefore 0 is equal to -2. Therefore, the
P
range should
cannot
be
be
all real
2.
numbers besides 2. Is that clear with everyone? Wait, can somebody type something in the chat? I feel like the chat is like disabled or something. Okay, that's good, that's good. Fantastic. Um, do we think we still need help on this too? Or are we like good with this level of problems? Okay,
Let's
I
go
feel
to the
like this
next
is pretty
slide.
easy, yeah.
So problem 1.5 is that suppose function p of x equals to 2 root x equal to 3 plus 3, but that p of x is only defined for x can only be between 4 and 9 inclusively. And question A is there a value of x for which p of x is equal to 5? Can you guys type the answer in the chat?
Right. If you assume, or I should say, how about this? You define the function big P of x that is equal to this, but then x, big P of x is defined for x, greater than or equals to 0. What it is? And denote as this, right? And then if you solve for p of x equals to 1, or p of x equals to 5 in this case, you get x equals to 1. However, let p of x is only defined from 4 to 9 inclusively, and 1 is not in. But with this notation means when an element is in a set. And this notation means the element is not in the set. So because 1 is not in 4 to 9, therefore there is no x that makes p of x equal to 5. So the answer is no. This is the range of p. All right, so we have an answer, and let's verify if it is correct. So first we can observe that as x increases, square root of x increases, right? Can you convince yourself that this is true? If so, then 2 of x is also increasing, right? So therefore, 2 root x plus 3 is also increasing. So therefore, the smallest value for p of x is when x is the smallest, which is 4 in this case. So 2 times root 4 plus 3, which is 7. Right? And the biggest value for p of x is just 9 because 2 times square root of 3. What am I saying? Square root of 9 plus 3 is equal to 9. And also you can see that for every value of p of x, you can find one x that corresponds to it. So therefore, p of x actually takes all the value between 7 and 9 inclusively. Still like this is the last one? No.
No.
All right, two more. So sad.
Mhm. So for problem 1.6, you need to find the domain of each of the following functions. For number A is function f of x equals to root 2x minus 5 divided by f x minus 3. So what is the domain of the function?
Okay, so it seems like this is the most popular answer. And let's verify if it is correct. So, in fact, for elementary functions, meaning that basically all functions that you see in your foreseeable math journey, most of the functions are not that restrictive in their domain. There are only a few that you need to pay special attention to. One is fractions. In most of math, with quite a few with like a very extreme exception that this is not defined when a is equal to 0. So that's one thing to keep in mind of. So therefore x minus 3 cannot be 0, right? So x cannot be 3, or also here. And another thing is whatever is inside the radical usually is not um less than 0. So therefore 2x minus 5 is greater than or equals to 0. So therefore we have like this um inclusive thing. And then there's like the 3 issue, and then there's no more other issues. So I think this is correct. And to find a range, no, no, it takes a little more work. For those who is interested in this, find the range of this. And also for those of you who are not so interested, find the domain of this function. Okay, so we can go in the same idea that first t cannot be 0 because we have a fraction here. And then t also, 3t minus 4 cannot be 0. So therefore t cannot be 4 over 3. And then this whole thing cannot be 0. So therefore 1 over t cannot be equal to 1 over 3t over 4. And how do you solve this equation? You can, Okay, so we got the following values for t that are restricted. T cannot be equal to 0, nor 4 over 3, nor 2. So therefore, negative infinity to 0, union 0 to 4 over 3, union 4 over 3 to 2, union 2 to infinity. Is correct? Yeah, seems like
Mhm.
so. Right, and I also prefer the other way, where you're writing in terms of R without. But be careful. So first of all, without is like this way. Another thing is you cannot write R without three, without 4/3, etc. There's no order of operation here, so therefore we have to write it as a set. R without 0, 4 with. Let me clear the board first. So R without, it should be without a set, right? So 0, 4 over 3, 2. And this is the answer.
So now going to problem 1.7.
So
Notice that x squared minus, okay, are we, oh, range of f. Okay. I don't think any of, okay. Steven, you muted yourself. So now we cannot hear you talk.
okay. Well, anyway, you should try this problem now. Right, exactly. This is like a very classic troll problem. You have to consider, so although this is like equal to x, question mark, they're not necessarily the same function. X squared minus x over x minus 1 is equal to x if and only if x is not equal to 1, right? Because otherwise you have 0 on the denominator, which is not very nice to deal with. So then they are the same function for x not equal to 1. However, they're not the same function when x is equal to 1. And in short, they're not the same function. So now we're going to move on to the next topic, which is to graph functions. This is a relatively big topic, but the basics of it is really easy to grasp. I'm pretty sure you guys have already learned it from like Algebra 1 or Geometry or something. Yeah, somebody mentioned that you can write if and only if as if. Nice observation. I like using this a lot. Okay, so essentially graphing a function, usually we graph a function that maps the real number set, well, or a subset of this to another subset of the real number set. So then you wonder to represent it, there's a guy called Descartes, he thought of a way. So in geometry, this plane form the plane, aka this thing. It's okay if you don't know what this means, but this is basically the plane. The plane does in fact represent um this mapping. So therefore, every point on the plane, you can usually denote it with like two parameters. Every point in the plane can correspond to um two numbers. So then usually we let x to be one of the numbers, and the other number we let it to be whatever that maps to x. It should be a concept that you guys already know. So I'm gonna move a little faster from now on. Usually you're dealing with functions that hit the x-axis as a more. So like here, here, here. Let's say here's our function. And here's an x-intercept, here's an x-intercept, here's an x-intercept, and here's the y-intercept. Normally, you only have one y-intercept. And who can tell me why? Let me repeat the question. Normally, your function will have at most one y-intercept. And why is that the case? Okay, so you cannot have multiple y-intercepts, it's not a function. That's true. By definition, a function is a mapping between two sets, domain and range, such that every point in the domain or every element in the domain corresponds to exactly one element in the range. So therefore, if there are multiple y-intercepts, then x equals to 0 will correspond to multiple f of x's. And that cannot be the case since x is a function. So therefore, for a mapping that is not a function, this is not necessarily true. For example, you can have a circle, which obviously intersects at 2 points. Yeah, this is a short example. You can probably easily see it. The two x-intercepts are here and here, -2, 0, 2, 0, and it's a -4. Yeah, -4. No, what am I saying? 0, -4. Are we good on this? Okay. Now we have some problems. For each of the functions below, graph the function, find the y-intercepts and the x-intercepts and the y-intercepts. Graphing it'll be pretty hard to put in the chat box. However, you can tell me the x and y-intercepts. You guys know how to graph a quadratic? I can assume you guys already know that, right? If anyone doesn't, I can explain it. Okay, I'll assume you guys know that. For a quadratic, there are several forms, and this is a very important form. Here is the value that is on the axis of symmetry. So this is 6. And this is like the function value for the vertex. I think we gotta move a little quicker. So this is -4. So therefore, what are the x-intercepts? And what are the y-intercepts? Yeah, be careful with the signs. Right, 4 and 8 is correct. How you can do this? There are a few ways. You can the way I like to do it is to look at the graph. Just stare at it for long enough. You can kind of see that this should be the case. Alternatively, move to -4. Okay. Yeah, you can set this as a function. So what does it really mean by for a function to have a certain x-intercept? It intersects the x-axis when the y-axis is like when y goes to 0, right? And when y goes to 0, y, it's just f of x. So therefore f of x is equal to 0. So therefore to solve this equation, you should get x is equal to 4 and 8. And for y-intercept, usually we denote it with x0, or a lot of physicists like to say x naught. And so y naught is, what is the y naught? So similar to the x naught, y naught is found by setting x as 0, because the y-axis is described by x equals to 0. So therefore, y naught is equal to f of 0, which is 0 minus 6 squared minus 4, which is 32. So yeah, 32 is correct. Um, this one is pretty easy. You guys don't have to do this. There's no x-intercept, and y is just 4. How about this? Let's do this as the last one. So the x-intercept, and okay, so we're getting some different answers. You know what? Should be -3, right? Or am I trolling? Did you make a typo? Yeah, yeah, okay. Well, how did you type √5 in the chat? That's crazy. All right, anyway, yeah, we solved the function, the equation. 0, 3, square both sides. It's plus 5 equal to 9, so x is equal to 4. Usually, when you're talking about the x-intercept, if you recall the definition of x-intercept, it is a point on the xy plane, right? And for a point, you cannot just say 4. You have to say 4, 0. It's a point. So similarly, for the y-intercept, you have to have this 0 in front of it, because it is a point. And it's like somewhere here, I think. Okay, good. So let's move on now. Also, feel free to ask if you have any questions. How many questions? Oh, we have a lot of Brahms. Okay, let's run through these two quickly. This one is about transformation, shifting up, shifting left. After you guys get this one and the next one, we can move on to the next section. Okay, so this is relatively harder to convert it into text, but okay. Adding 2 to f of x would mean adding 2 to each bad value. Yeah, that's correct. Which means it shifts up. Yeah, exactly. Shifting left is relatively less intuitive to understand because you're thinking of adding values to x, but then you're shifting it in the negative direction. Like I said, the way I would understand is to consider a specific point on this. How about this? Let's consider this point. So then you're having f of x plus 2. Then the point here, this point is going to have, when this point is added to on the x component, then its y component will be 0, right? Is it making sense? Are you remembering the stuff from algebra 1 or algebra 2 or something? So it is shifted left because every point corresponds to a point that is like 2 units to the left of it. Okay, that's great. Find out the minute range for this. After this, we'll be able to move on to the next section, and hopefully after the next section, we can have a 5 minutes break. This class is 2 hours. It should last until 8:30. Okay, am I hallucinating?
No, you're right.
Yay. Alright, the main it's projects 1, 2, 3, 4, 5, 3, 4, 4. After you shift it left by 3, yeah, it should be if 8, 0. And the range should be, yeah, move it down, so what? Oh, wait, this is 3, never mind. So -7, 0. Make sure you write it such that the left number is like smaller. It's just notational issue. Yay, we can move on now. Uh, nah, you guys understand this.
So now we're going to rate of change.
Oh, wait,
Are
somebody
we
is requesting a explanation for B again. It's like,
okay?
hmm. How about this? We're gonna have a concrete example. So here's how I memorized it. If you have the function y equals to x, right? So when you're adding 2 to x, y of, or I should say y is, right? This is clear? If this is true, then you're shifting it this way, up by 2. But up by 2 in this case is also left by 2. That's like a concrete example for you to remember this fact by considering simple cases. Does it make more sense, or do you want me to? Okay, that's good.
So now we're moving to rate of change.
Yay.
So usually the rate of change, often called the slope, it measures how much the output change compared to the input changes. So if we have 2 points x1, y1, and x2, y2, the rate of change would be the change in the output, which would be y2 minus y1 divided by change of input, which would be x2 minus x1. Note that you have to do the points in the same order, which means that you cannot have y2 minus y1 over x1 over to minus x2. So if we have a function f of x on the interval a to b inclusively, the average change of the function would be f of b minus f of a divided by b of a, or f of a minus f of b divided by a minus b. Both of them works. And if the rate of change is positive, consider that you have a positive slope, the function is increasing on an average basis, as shown in the graph. And if the rate of change or the slope is negative, the function is decreasing on average. We wrote on average because it's between 2 points, doesn't necessarily mean that the whole function in this interval is decreasing or increasing. And if the rate of change is 0, the output did not change overall between the 2 points.
All right, so we're gonna do an example of rate of change, and then you get your break. Yay. So here's a really quick example. If you get it, you can just do this problem. So consider the function f of x equals to x squared, and then find this. First we can try to graph it, because the rate of change is just the slope. So here you have a parabola. X equals to 1, x equals to 4 here. Yeah, you just plug in the numbers and you get this. It's pretty easy. And what it means is that the line here has a slope of 5. Is that good? Yeah, okay. A is probably correct. Let me do this real quick. Yeah, it's A. Yeah, right. Yay. Alright, so we can move on to the break now. Anyway, because like the thing y equals to x squared is a parabola, so for those of you who do not want to take a break, you can try this problem. I thought it's pretty cool. If you have this parabola, y equals to x squared, and then if you have like two tangent lines, such that they meet on the y-axis, and then for any line here, alright, this is not a very good graph. And then if you have like a line here, tangent to the graph, and it meets the two tangent lines at these 2 points. And then if this length is A and this length is B, prove A plus B is fixed. As let's say this tangent point is T. T moves along f of x. Alright, let's have a break. Yay.
We're gonna have a 10-minute break.
Uh, that's crazy.
Well,
Yeah,
it's
sure.
only 7:23, so we're gonna get
Yeah.
back at 7:33.
Okay. All right, please come back, everyone. Jane, are you back?
Yes.
Yay, good job. Out of curiosity, has anyone made any progress in this problem? Yes, I'm really impressed. Uh, you should also submit this problem as part of your homework if you solved it. You know what? I'm gonna screenshot it. Although this is not a very nice problem statement. Maybe I'm gonna type it up. Hmm. Alright, anyway, so let's move on. Composition.
We're going to talk about composition.
Yay.
So composition is when we take the output from one function and put it into another function. And the expression f of g of x, or as in this label, would means that we put the input into the function g and then take the output g of x and then put the input into the function f. However, in most cases, f of g of x is not going to equals to g of f of x. If you want to calculate g of f of x, you need to put the x input into the function f first, and then get the output from function f as an input for function g and get the output for that. And an example would be suppose that function f is equal to 3x minus 7 and function g is equal to 2x squared. And I want you guys to try to find the output value for f of g of 3 and g of f of 3 respectively and put it into the chat.
Okay, we have quite a few answers. Yay.
Yeah, I saw the answers are 47 and 8 for the second one. Do
Yeah, I think so.
Does anybody need me to go over it?
Well, you should still like say because like some people are
Okay,
yeah,
I will explain it.
yeah,
So
good
for the
job.
first one, if we want to find function f of g of 3, that would be um ha- that would be if we calculate g of 3 first, that would be f of 2 times 3 squared, which will be 2 times 9, f of 18. And if we input the value 18 into the function f, we would get 3 times 18 minus 7, which is 47. So that is correct. And for the second one, if we have g of f of 3, that would be equals to g of 3 times 3 minus 7, which is going to be 9 minus 7, g of 2, which if we put into g, that would be 2 times 2 square, which is 8.
So one
Yes.
thing you can notice here is that they're not equal.
Yeah.
And which means that function composition is an operation such that it is not necessarily commutative. Commutative. Do you guys know this commutative?
We should.
Commutative means consider an operation, let's denote it like this, and assume it is not XOR. And for this operation, if P like this thing Q is equal to Q, this thing P for all. That's why I'm gonna just write for all P Q. If you have this, then this operation is commutative. However, in this case, it is not, as G F compose G is not equal to G of F for all F and G. Because here we found one example such that they're not equal to each other. This is
Mm-hmm.
just one thing to keep in mind of. Because for example, addition, multiplication, a lot of these operations are commutative. Subtraction, division are not. And also, yeah, there are some other ones as well. Later, we'll be learning about matrix multiplication, that is not commutative, but dot product between vectors is, and cross product between vectors are not. It's just one thing to keep in mind of. Inverse functions. Oh, we're almost done. We can go through some homework questions after this. What do you think, Jane?
Sure.
Are inverse functions. So, hmm, consider this. So, you have a lot of operations for numbers. You can also have operations for functions. Previously, composition is one of the operations between functions. It takes the output of one function, it feeds into another. Um, However, this operation you have to have two functions. In fact, exactly two functions. So you can apply this operation. But there's also examples of operations that only need one function. And inverse is one of such examples. For inverse, we denote it as this, negative 1. This is because for composition, f, if you compose f with itself, sometimes you write it as f2, sometimes f3 if you have to compose it 3 times. And in general case, n. Right? But n is like a natural number. It cannot be negative. Um, but that naturally motivates the question of what function composed with f will be just x. It kind of undoes the effect of f on x. It cancels it out. So therefore, we define such function to be the inverse of f. Sometimes it exists, sometimes it doesn't. And here are some examples. So the function f really just does something on x. In this case, it multiplies it by 3 and then subtract 5 from it. And then from the lens of composition, you can compose f like a few times and change x some other times. But then you want to understand what function undoes the change of f. The way you'd solve it is often you're taught to do this. And then you solve this equation, which is, but because it is the inverse, how about this? Let's go back to the mapping nature of f. This is domain, this is range. And then every element here maps to an element here. So we want to find a relation that reverses all the arrows here. And as you can see, if two arrows are pointing to the same element, assume these two elements from domain is pointing to the same element in range. Then when you're having the inverse relationship, it is no longer a function. Because this single element is corresponding to two elements in domain, which is the new range. All right, so with the concepts, let's actually solve this problem. Okay, the first one, I think it's solved. Oh, C, it's solved. And it is solved in this very classic way. To just get the solution, why this is the inverse function of f. Okay, that's good. Yeah, and in the last one, you can just directly verify this. All right, so enough being said, can you try to do these two problems? Because we have quite a few people saying that 2 should be the answer for A. Let's check it. So what does this really mean? So it's saying that for some value, let's say K, we have this. Since it's an equation, we can apply F to both sides. Right? But since by definition, F inverse and does the effect of F. So therefore you can also say F and does the effect of F inverse. So therefore F of F inverse of 7 is just 7. So you're finding for some value of K. You have F of K is equal to 7 and you solve it. F of K is equal to -5 minus K over 3 minus 2K equals to 7. I don't really want to solve it, but you can plug in the 2 here. So -5 minus 2, 3 minus 4 is indeed like 7. And we seem to have some answers for B. Okay, so previously we had this method of solving for the inverse. Let y be the inverse, no, just f of x. X is equal to -5 minus y 3 minus 2y. Do we first understand why this is true? Okay, I assume we do. So then we are just proceeding to solve this equation in terms of x. So therefore, we multiply this on both sides. But you have to first notice that y can never be a derivative. So therefore, 3 minus 2y times x is equal to negative. So 3x plus 5 is equal to negative y plus 2yx. Taking y out, you have 2x minus 1y. Dividing this on both sides, you have y is equal to 2x. Okay, so that does seem like we got. However, you have to it's kind of already implicitly noted, but you can also just add x is not equal to 1/2. But we understand this problem. Okay, it seems like the solution that most of you guys got is indeed correct. Okay, so let's move on. I'm gonna leave this problem to you guys now. So these two problems are in regard of the criterion for a function to have an inverse. Okay, we have quite a few responses, and I'm gonna talk about the solution now. In the first one, does this have the inverse? Hmm. Since we have plenty of time, do you guys want to talk about your solution? You can just unmute yourself and talk about it.
No, it doesn't have an inverse.
What's your justification?
So basically for this is a parabola, so for each so like basically for each y value there are two possible x values that satisfy it, excluding the vertex. So therefore it can't have an inverse.
Okay, that's good. I think it is called um the horizontal or vertical line
Yeah,
test
so
or
like
something.
this one it fails the
Uh,
horizontal line test.
right. So you can like write it in terms of y and x and have this. Yeah, and then it fails the vertical line test for a function. So therefore we conclude that there is no inverse for this. That's correct. Good job. And now let's consider B. There are quite a few responses. this. This one should be yes. And why is that true? Can I have someone besides Alexander to talk about this? 1 to 1. Why is this 1 to 1?
It passes the horizontal and vertical line test.
Hmm. Okay, how about let's phrase it this way. So let's say I have a value for this is equal to y. And for a specific y, there is exactly one x that is equivalent to if you solve the function of x in terms of y. You can square this. What am I writing? So you can subtract 1. However, the thing is, every step you have taken here is a 1-to-1 correspondence. Think about it. When you're subtracting 1 on both sides, the value, let's say m and m plus 1, there is a 1-to-1 correspondence. There is a map. And when you're dividing by 2, there is a 1-to-1 correspondence. Now, how come this doesn't have one? This is because when you're solving it, there's square root. And it is not a 1-to-1 correspondence in the sense that you can have either plus of the square root or minus the square root. So in this way, you should be able to solve this. And this is in fact equal to y squared minus 10 minus 1/2. And of course, we usually express this in terms of x. So we have this way you guys got. There's supposed to be the square here, right? We're not trolling. Yeah, it has to have a square here, right? Because this one is like a half parabola. So therefore the inverse has to be like another half of a parabola, right? Okay, that's good. That should be correct. Let's see how many problems do we have in this. Okay. Explain how to determine from the graph of a function whether or not the function has an inverse. Okay, you guys already said it. Pass the horizontal line test. The function like, for example, this one does not have an inverse because, for example, you can draw this line, and this line intercepts the function at multiple points. Can anyone give me a justification for why this horizontal line test is valid?
Because like the horizontal line test like basically tests whether like there like this point had this y value has two separate values for x or not. Like if a horizontal line hits the graph 2 times, then it fails since like say it's y, then there's multiple values of x that like make f of x equal to y.
Right, exactly. To rephrase it, they can say, oh, if you think about it, what really is a horizontal line? It is described by y equals to some value of y. Let's say why not? Because why not? So um the amount of intersections, the intersections are described by this because they lie on this line. but they also lie on y equals to f of x. So if this system of equations have more than one solutions, that means y0 equals to, that means this have more than one solution, right? Which means that one value of x is corresponding, or I should say two or more values of x is corresponding to the same value of y, which cannot be the case by the definition of a function. And for b, it is fairly the same. It is a reflection with respect to y equals to x. Let's say this function. And why is this true? How come if a function has the inverse, then it has to be the relationship between a function and its inverse is the same as the function, the graph of the function along with the image of reflection over y equals to x. If we're to okay. Yeah, I can just unmute yourself.
So basically, if we have the points like x, fx, then the inverse function would hit like the point fxx. So then there have to be reflections over y equals to x.
Right, exactly. The reflection principle is true for any point on the graph of f of x. Therefore, it must be true for the entirety of the graph. Suppose functions f and g both have inverses. Show that if h is equal to f composed g, then h minus 1 is g plus f. Says it really is inversed. And for those of you who are curious, later on over the summer you're going to learn something about matrices. And then you'll find out that it is true for matrices as well. And not only for inverse, but also for transpose. Now I can think about it for a second why this is true. It's not entirely obvious. Yoran, can you unmute yourself and talk about this? It's kind of hard reading.
So it's
So
like
this-
h inverse would be like h inverse of h would be like g inverse compose f inverse compose f compose g. So then that would simplify down to g inverse compose g, which becomes x. So then h inverse of h of x should equal to x.
Yeah, that's pretty cool. Because this is identity, so this is x, so it just disappears and this disappears. Yeah, that's true. And this is the exact same reason why it is also true for matrices. That do you guys understand what I'm writing here on the bottom? If you don't, it's totally okay. But the thing is the same argument. Notice that the argument it has nothing to do with the fact that f and g are functions. If you look at it closely, it does not rely on the fact that f and g are functions, meaning that they can be other stuff too. And it does not specifically require inverse to be like the reverse mapping between like the two sets. So therefore, if you have like another operation that kind of flips between two binaries, And then if you compose this operation with itself twice, it becomes the same. Then you can apply the same argument and you can generalize the case to um, other fields of math. And this is a quite common phenomenon as well because one example is that the geometric series, the argument for that is x. And you can find some of this by constructing something multiplying to this. And then you subtract the two. And this argument would work for a lot of other things too, beyond geometric series. Okay, so we are going to get a review now.
Okay, so for the review part, we're going to go over all the definition that we covered in this class. You should go to the next page. So we go over domain. That's all the values we're able to input into the function and get an output. The range, that's all the values that can come out of a function. Real valued function, aka real function, which is a function that can only output real numbers. And interval notations, which we use to represent a continuous range of real numbers along a number line. And we've also covered x and y-intercept, the x-intercept being the point where the graph crosses the x-axis, which is the point or the points that the graph where y equals to 0. And then for y-intercept, is going to be points where the graph crosses the y-axis, which is the point where the x is equal to 0. When we go to composition, it's when we take the output from one function and put it into another function. Be aware of the order that the composition. In the composition, the calculation order matters, which means that the function f of g of x is not going to be equals to function g of f of x. And for inverse functions, it's a function that undoes the work of another function. We have half an hour left. So we're now going to go over the homework.
We're probably gonna do a few selected problems.
You don't need to do every single problem that's listed here because that might be too much for you guys.
Also later on in the week, probably Wednesday or sometime, we're gonna post the answer key. I'm not too sure if the answer keys are available in the textbook. If they are, feel free to check them after you finish. And if you're really stuck on a problem, you can skip it, and you can ask it on during the office hour. Is it
On
Wednesday?
Wednesday and Saturday.
Okay, that's good. All right,
Jane and
let's look at some
Yunfei,
problems.
sorry, when do you mind sharing the specific time of a Wednesday office hour?
Oh, yes. Let me find
Let
it
me
from.
double check.
I think it's 6, right? Trey, am
Okay,
I correct? Oh no, it's also 6:30. Okay.
We can do 6:30 to 8:30.
okay,
So,
sounds good.
well, yeah, it's 1 hour, right?
It's 1 hour, right, it's
Oh,
1 hour.
okay.
So 6:30 to 7:30, would
7:30.
that work?
Yeah.
Okay. Then I will send out an email afterwards, after this meeting. And I will also include a Zoom link for the office hour. Thank you.
The office hour, you don't have to attend it. It's not mandatory, but if you do have any question on the homework or on this topic, you can use the office hour to ask us any questions.
Yo, Jane, can you pull up the textbook and
Text
see some problems?
chat. I'm on my iPad right now, bro.
Okay. I'm gonna stop sharing for a second. Why don't we go over some problems in the AOPS Precalculus book?
Me Sure. Do you want to share? Okay, you're sharing the
Yeah.
screen.
Oh, you know what? This seems kind of relevant. How's the graph related to? Okay, so you do not have to have any idea on sine and arcsine for now. However, you
Mhm.
do have to know for a fact that um arcsine is the inverse of sine. And you can forget about the mean and range like for 1 second and let's see if you can come up with anything about this too. You're able to answer this question even without any knowledge on sine, arcsine. Okay, so the answer here is that it's just that they're inverses of each other. So it's like reflection of your y equals to x.
Are you in chapter 2?
Hmm. Well, if you're talking about function basics anyway, so we can also just talk about periodic functions, which will prepare you guys for the next section. A function is periodic. If yeah, the definition is just here. But you have to note for a fact that this is true for all values of x. Well, on this domain. And sometimes you're gonna have the smallest fundamental period, but sometimes you do not really have it. Um, you guys don't really have to know this, but or consider this function. X minus floor of x. In this case, it is periodic. And the smallest period here is 1. Because if this is f of x, then f of x and f of x plus 1, they're the same function for all x in this domain, which is their real number set. However, you can also notice that it doesn't have to be 1. You can also have it to be like 5 or 6 or 7 or anything. As long as it is a natural number. Or, you know what? It works even if it is negative.
So
And
like
here we have the
zero.
period to be the smallest positive number you add here such that they're still the same. Because if you add, for example, 1 over 2, then they're no longer the same. So 1, you can prove is the smallest fundamental period of this function. And if you have another function, for example, x minus 4 x over 2. And in this case, it is still the same. But as we have said for transformation, if you do this, now the period is 2, um, rather than 1. And then there's also some other functions, such as y equals to 4. Is this function periodic?
Technically, yes.
Does it have its smallest fundamental period?
No, like the period is like 0.
Period is the period can never be 0, right? Because by
Because
definition, the
there isn't
period is
any
like the thing
smallest
you add,
fundamental
right?
period.
It's like the thing you add here. So, and by definition, it's non-zero. But yeah, it is because for any period you gave me, I can always find a smaller period. Like if you say the period is between like these two um vertical lines, you can always zoom in and find there are like even smaller periods. So in that case, we say that there is no minimal period for this function. Is there any other example of this? I cannot think of any. Yeah, sine. Sine is indeed one. So let's try some other problems.
$46 for the AOPS book, not for the textbook.
Yeah. No, okay. Wow. What problem do you guys want to do?
1.38, we can do that.
1.47.
Okay. Well, I know we can do other problem that's interesting too. All right, I'm gonna try 4-7 with you. There's no way this problem is from Amy. It's crazy. If you get any answers to any of these problems, you can just type in the chat and I can check it for you. All right, I'm gonna explain 1.47 now. Let me stop sharing so I can change this screen to my other screen for a second. Here and here. What was this? All right, so the problem states that for a function f of x equals to if you do not fully get a solution for this problem, it's okay. It might be a little beyond pre-calculus. However, the techniques used should be within the scope of your knowledge. So if you have this, you're also given that f of 19 happens to be equal to 19 and f of 97 is equal to f 97. And quite obviously, this problem is from Amy 1997. And also f of x is equal to x. So therefore, we can apply the knowledge you learned today upon inverse function. Since this is true for all x, with a minor exception, you can apply f of negative 1, which is f inverse, to both sides. And then by definition of inverse, this cancel with f. So you have f of x is equal to the inverse of f of x. And how do you find the inverse of f? Does anyone want to touch on that problem? In what way can one find the inverse of f? Right, reflection is a way, but reflection is more of a geometric way. However, in this case, you want to find the exact expression for f of minus 1. And how exactly would one do that? We have learned this way, right? If we can set f of x as x.
Yeah, this one like x is equal to a, like f inverse of x plus b over c f inverse x plus d, and then solve for f inverse x. Later,
Right.
you find that it's like dx minus b over a minus
But
c.
okay, give me a sec. Let me close this so I can write it down. Oh yeah, can you repeat that? What did it say you got to?
I think it's like dx minus b over a minus cx.
C minus, what, can you repeat that?
It's dx minus b over a minus cx.
Okay, that seems about right. Um, hmm. Somebody can verify what that was this mess. But yeah, assume this is correct. So you have this is equal to f of x, which is all right. And now what can you do? Yeah, this is too slow.
You can like equal, and then we also have f of x equal to f inverse x.
Right. So you have so this is not that easy to deal with, but you can cross multiply. And I'm not gonna actually yeah, sure. AC x squared minus AB is equal to DC x squared minus BD. Right? So then you can see that since this is true for all x, when x is equal to 0, then we have negative AB is equal to negative BD. So therefore, A should be equal to D. I mean, where B is equal to 0. And then similarly, you can also conclude that C is equal to 0 or A is equal to D. Okay, so this is some information you can get from this equation. And then now let's see how can we fully exploit these two information. Alexander, what's your idea?
think like we could just plug those in. Not
Yeah, that's one idea. Or another way you can do this is um notice that f of x minus x equals to 0. In this equation has two solutions, 19 and 97. And the
and
reason
it's
I
like of
did
the
this,
form like x minus 19 times x minus 97 and times c.
right. But you have to first write it like this. But this is still not that easy to deal with because we want a polynomial to work with. However, since we are excluding this from our domain, so this is never 0. Therefore, we can multiply this on both sides. Therefore, we can get ax plus b minus cx plus d times x is equal to 0. And this is a quadratic in terms of x. It is precisely minus cx squared minus plus a minus d x plus b is equal to 0. And as you know, this should be equal to negative c x minus 19 x minus 97. This is equal to 0. So we can expand it, and you should have another a few other relations between A, B, C, and D. So now we had two relationships from the previous condition here. And in here, we also get some relation from A, B, C, and D. And due to time, I'm not gonna go into like the full details. But you should be able to solve for A, B, C, and D. Even if you do not, let's look at what we have to find. So they're saying that there's precisely one value that is not included in the range of f. So previously we had this another problem that we said there's like also some variations of a inverse relationship. And then there's exactly one value here. And then one is something not in this. So let's say this is equal to k. And we multiply this on both sides. Ax plus b is equal to k times c times x plus kd, right? And this never has a solution if they are not equal, but these two are equal. So there's no solution if b is not equal to kd, but a is equal to kc. Therefore, k is equal to a over c, given that this is true. So after we have found A, B, C, D, we have the answer that we want to find is K equals to A over C. You do not have to fully understand how to like get the answer here, but I want you to have a few important takeaways. So first, you want to use is okay. This I'm not sure what I mean by that, Isaac. Which problem is I see. I know we can wait, let me first finish. So we learned that you can apply f inverse on both sides of an equation. In this case, we applied it to this equation. Right. And another takeaway is that um the domain and range of a function of this form both lack exactly one value. And we learned how to find that value. Because we can set it as k and there's precisely one value such that these two cancel out, but they're still not equal. And 1.4, I can do that real quick. If you have to go, you can feel free to go now. This okay. It seems like your answer cannot be like, huh. Oh, never mind. That's hallucinating. I can rather shift this. Hmm. Let t be x squared. So this is shifting to the right two. So this is u minus two. Um, oh, actually, how do you do this? You're trying to help me out. I might be a little trolling here. Let's do it.
41.
Yeah, yeah.
The way I did it, I did t equals x squared plus 1. So
Okay.
then you just make f of t
Mm-hmm.
uh equals,
Oh, you actually solved for
yeah, like that.
oh, okay. Well, that's how it works. Um, solved if some t square plus some t plus something, and then you plug in f of t minus 2 into this. You're gonna get another equation. Okay,
Yeah.
that's good. If there's no further questions, today's section will be concluded. Do you have any questions for today's lecture with regard to functions? Alright, if not, I'm gonna stop the recording here and you're free to go now.